It's solar powered, so it can recharge just on the go. We have 4 panels up here that supply it, and here's our charge controller right here. So it charges all the batteries. We have 8 8-volt batteries for a total of 48 volts. And we have an air compressor because we have pneumatics on this cart for our braking system. And over here is all the valves for it. We have 1 for our main brake and then 2 for the emergency brake in case something goes wrong. And then coming up here is all the electronics for it. So currently all the computation is handled by a Raspberry Pi 4, which is this component here. And then we just use a touch screen for all of our controls and deciding what we want to do. We no longer have a switch for our forward and reverse, so it's handled by software. And relays. Relays make up most of this. So the different modes we have are the manual, as you can see here. So it puts it in forward, reverse, or neutral. And then you're still able to use everything as though it's just a regular golf cart. And then if you want to use an Xbox remote for some remote capability, then we just have this Xbox One remote, and it allows you to control everything. We have a massive stepper in there, which is what powers the steering. And you can also do the forward and reverse using this. So here's the forward mode and reverse, and you can change the rate of the steering just using this D-pad, because the steering is a PWM signal and it varies the frequency for how many steps it does. So you can increase the amount of steps and it'll turn faster or slower. And for the steering, for just the regular drive, it's also PWM, but it varies the voltage. So we have a level shift circuit and then an RC filter to give it between 0 and 5 volts. And that is how it knows how fast to go, as you can see here, or just reverse. On the remote, in order to choose forward or reverse, you have to do this. So it kind of acts as a dead man switch. So if your hand falls off this, it's not going to go anywhere versus that. And then our braking, as I said earlier, was pneumatic, so that's the left trigger. So if you're going forward, you can just hit that and it'll stop relatively quickly. We have quite a bit of pressure in there. And then you can hear it release the air. We have a train horn on top of this thing, which is our Y button. This massive horn up here. It works great. Can definitely get people out of the way. Another control mode that we have is the serial mode. So the library for the serial, it's pretty simple. We just made it ourselves. But how it works for this is you'll send like a $ and then you'll do like MF100, which would stand for motor forward at 100%. And I've converted that into just like a WASD thing. I don't know if you can see it because it's very bright out, but it just runs on my laptop here. So then I can do A and D for just the steering. So that would be a stepper L 2000, so stepper left at 2000 hertz. The serial is really important because the goal of this project is to have it be self-driving. So we'd offload the computation to something else that would run that, and then they would just be able to send signals to our Raspberry Pi, which would control everything there.
Perfect. Thank you. Thank you. Anything else?
Mike, do you want to talk